Okay, hello. Today we're going to be talking about angles and parallel lines, and we're going to be going just through some rules and theorems about how to find different angles given two parallel lines and what's called a transversal. Okay, well, first of all, let's talk about parallel lines. So here I have drawn two parallel lines, and parallel lines, it's important that you know that parallel lines never touch. Okay, parallel lines will never touch. Okay, so they're drawn with arrows like this, indicating that they're parallel. Okay, the arrows indicate that they're parallel. Now, one other thing that you need to know is if there's ever a line that cuts two parallel lines, this line is called a transversal. This line here, is called a transversal. Okay? It cuts parallel lines, okay? And we're going to talk about a few things here about transversals and parallel lines. First, we have to talk about a couple just basic things. We talked about in a previous video, okay, if I have a straight line here and it's cut by another line, okay, then these two angles here have to add up to 180 degrees. Because if I took a protractor out, okay, and I took a protractor and I put it over here, okay, and I measured this, angle here, it'd be 180 degrees, okay, so if I cut it, and that one's 70 degrees, okay, thank you, protractor. If I cut it and this makes an angle of 70 degrees, then this angle, then you know, supplementary angle theorem says that the two angles add up to 180 degrees. Okay, so x plus 70 has to equal to 180 degrees. Okay. These two angles add up to 180 degrees, so therefore x would have to be equal to 110 degrees. Okay? Now, complementary angle theorem, okay, is this case whenever you have a 90-degree angle and it's cut by another line, and you know one of the angles, then you know the sum of those two angles has to add up to 90 degrees. So I know here that y plus 35 degrees has to add up to 90 degrees. Okay, so therefore y would have to be equal to 55 degrees. Okay. All right. Let's move on now to a couple other things here. Now, the opposite angle theorem says, okay, so if ever there are two lines that cut each other, okay, this says that this line, this angle here, and this angle here are the same, okay, and then this angle and this angle are the same, okay, the opposite angle theorem. The opposite angles are the same, or sometimes it's called the X pattern, okay. So, for instance, if this was 100 and, if this was 140 degrees, then this would be 140 degrees. Well, if this is 140 degrees, then by the supplementary angle theorem, okay, this angle here in red, well, the red plus the green has to add up to 180, so this angle here has to be 40 degrees. And if this angle is 40 degrees, then this angle is 40 degrees over here. Okay? All right. Now, getting back to our parallel lines and transversals, Okay, if I have two parallel lines and they're cut by a transversal, okay, we have something called the corresponding angle theorem that states that corresponding angles, basically the intersection of the transversal with each parallel line, right, this angle here, are the same. Okay? It's also called the F pattern because if you look, if I draw on the transversal, there's the first part of my F, here is an F that you see gets made here. So both angles in the F are the same. Okay, 100 degrees here. Now, it also works for backwards Fs. So, for instance, because this transversal here, the angle here made with a backwards F, that means that this angle and this angle are the same too. Well, if this is 100 degrees, then by the supplementary angle theorem, then this is 100, this has to be 80. So this is 80 degrees here, 80, and this angle is also 80 degrees here. Okay, so that's the corresponding angle theorem. All right, and we'll get to a couple other theorems, angle theorems, in our next video.